Hey everyone. So today we're going to talk about another paper for Pure Maths 3, variant 3.2 of the October-November 2024 series. So let's see the first question. Expand 9 minus 3x raised to the power of 1 over 2 in ascending powers of x, including the term in x squared, simplifying the coefficients. Okay, so first off, we need to deal with the 9 minus 3x because we need it in this form. So to get rid of this thing, to make it into 1 minus form over here, we need to take out the 9 or factorize the 9 out. We will get 1 minus 1 over 3x. So which means that if this is raised to the power 2, this entire thing will also be raised to the power 2. So 9 raised to the power 1 over 2 is basically 3. So 1 minus 1 over 3x, 1 over 2. So further what we can do. First we can expand this 1 minus 1 over 3x, 1 over 2. So the formula, I think we're all familiar with this now, but let's still talk about this. So we have 1 plus n times by ax plus n minus 1, 2 factorial ax whole squared, and so on. So that's what we need. And also, I deliberately changed the sign over here. So in the expansion, the minus 1 over 3x will come. So 1 plus 1 over 2, which is n, ax, which is minus 1/3 of x, plus 1 over 2 minus 1 over 2 because n minus 1 divided by 2 factorial and then minus 1 over 3x whole squared. We just only need to go up till x squared term. So let's simplify this. 1 minus 1 over 6x plus minus 1 over 4 divided by 2. That becomes minus 1 over 8, 1 over 9x squared. So this simplifies to 1 minus 1 over 6x minus 1 over 72x squared. Now, when we multiply the 3 with this thing, so all the terms are multiplied by 3. So 3 minus 3 divided by 6 is 1 over 2x minus 3 divided by 72 is 1 over 24. And that's it. That's your final answer. All right, moving on to the next question. By sketching a suitable pair of graphs, show that the equation cot 2x equals to secant x has exactly one root in this interval. Okay, now there are two ways to make this. Either we make it in this form, which you should be able to do this by now, or we could make reciprocals of these into the tan and the cos form and then do that. So it would be exactly the same because the question says sketching a suitable pair of graphs. So we can do it both ways, but you should be able to do in both ways also. So you should not be restricted to just the simple tan and the cos one. However, mastery over them is required. All right. So let's see if we make them this way with a cot form first. So if we have this, and remember we only have to go to 0 to pi, half pi, sorry. Now, what this times by 2 does, it reduces the period by half. So usually the period is 180 pi or 180 or pi. The period will then be reduced by half to up to pi by 2. So let's go with pi by 2 over here. This would be pi by 4. And let's draw a dotted line over here because this is where the crossing will happen. Now, the difference between this is that the graph goes like this, the chord graph. So we will have, let's use this. So rather than going up till full pi, it's going to go up till pi by 2, sorry. It's going to go up till pi by 2. So this is your cot 2x. Secant x, on the other hand, it's the uh, reciprocal of cos. So it's going to go like this. So this is your 1. And this is also an asymptote for the secant also. So this is your secant x, and this is your cos of x. Sorry, no. This is secant x, and this is your cot x, sorry, 2x. Now we can see over here there's only one point of intersection here. So that means only one solution to this problem. Now let's see whether we have the same thing in the reciprocal form or not, in the tan and the cos form or not. So we will have a similar thing. We will have pi by 4, pi by 2. We will draw lines over here. Oh, sorry. Here. Okay. So the tan 2x will go like this. Like this. And the cos, so basically what we have over here, we take reciprocal on both sides. We have tan 2x equals to cos of x. So the other one is cos. So that's just simply going this way, which is 1 over here. Also, you can see the same thing over here. The root is below pi by 4, so only one root over here. So cos of x and tan of 2x. So that's all we have to show over here. So only one point of intersection. Indicates only one root in the given range. Alright, so that's what we just have to show. Show that if a sequence of real values given by the iterative formula converges, then it converges to the root in part A. So this means that when we reverse this into the formula, that is x equals to half tan inverse of cos of x, and when we rearrange it, we will either have the form cot 2x equals to secant x, or we will have the form tan 2x equals to cos of x. So these are the forms that we want over here. So let's see whether we get or not. So 2 goes on the other side. This becomes tan inverse of cos x. We reverse the tan. This becomes tan 2x equals to cos x. So this is one of the forms that we were looking for. Now, if we take the reciprocals of both sides, we get cot 2x equals to secant x. So this is also one of the two forms. So what we just simply need to write, therefore, iterative formula converges to the root of cot 2x equals to secant x. That's it. Alright, the square roots of 6 minus 8i can be expressed in the Cartesian form x plus iy, where x and y are real and exact. By first forming a quartic equation in x or y, find the square roots of 6 minus 8i in exact Cartesian form. So we know, since we're talking about the square roots of 6 minus 8i, so that means the square of the square roots will be back to 6 minus 8i. So this means that 6 minus 8i can be written as the square of x plus iy. So when we expand the square, we have x squared plus 2xyi plus yi squared. Sorry, I squared y squared. Now, I squared is equal to minus 1. So this term over here becomes negative, leading us to x squared minus y squared plus 2xyi. Now this is identical to 6 minus 8y. So we then equate the real part with the real part and the imaginary part with imaginary part. So 6 equals to x squared minus y squared, and minus 8 is equal to 2xy. The second one leads us to, let's say y, for example, minus 8 over 2x, which is minus 4 over x. So we substitute this back into the equation with the 6. X squared minus whole squared. So this thing, when we square it, minus will be taken care of. So we will have 16 over x squared. Now, furthermore, what we can do over here, we can multiply both sides by x squared, leading us to 6x squared equals to x raised to power 4 minus 16. And when you take everything on one side, x raised to power 4 minus 6x squared minus 16 equal to 0. So this is our quartic equation. Now, how do we solve this? We solve this with quadratic solution. But the coefficients are easy. You can do this with the factorization also, or the sum and product rule. So if u is equal to x squared, then the upper quartic equation becomes u squared minus 6u minus 16 equal to 0, which when you try u squared minus 16 minus 6u, so when you try this with 8, 2, and 8, we can get 6. So 8u, 2u, 8 is negative, so we get u plus 2, u minus 8 equal to 0. Therefore, u is either minus 2 or u is 8, which further means x squared is either negative 2 or x squared is 8. This one obviously does not yield us to any solutions. So x would be plus or minus square root of 8, which is 2 square root 2. Now, we said y is equal to minus 4 over x, so that's what we have to do over here. So when x is 2 square root 2, y would be minus 4 over 2 square root 2. When x is minus 2 square root 2, y would be minus 4 over minus 2 square root 2. So in both the cases, 2 times by 2 times by 2. So 2 divided by square root 2 is just minus square root 2. And 2 divided by square root 2 is just 2 square root 2. So therefore, square roots are plus 2 square root 2 minus root 2I and minus 2 root 2 plus 2 root I. That's it. All right, moving on to the next question. Solve the equation 5 raised to the power x equals to 5x plus 2 minus 10. Give your answer correct to 3 decimal places. All right, so if you notice over here, 5x plus 2, if you remember the indices rule, we can write it like this, making it into 25 times by 5 raised to the power x. So this becomes 5 raised to the power x equals to 25 times by 5 raised to the power x minus 10. Taking the 5 raised to the power x terms on one side, 25 times by 5 raised to the power x minus 5 raised to the power x equals to 10, leading us to 24, 5 raised to the power x equals to 10. So 5 raised to the power x is 10 over 24, which would be 5 over 12. Now, what can we do further? So this is an exponential equation now. We have to use the exponential way of doing this. So either with the ln log base 10, either way, whichever one is more suitable for you. So if we do this with the ln, let's see how this would go. So this would become x ln 5 equals to ln 5 over 12. So x would be ln 5 minus ln 12 divided by ln 5. If we go with the log, x log 5 equals to log of 5 over 12. So x would be log of 5 minus log of 12 divided by log of 5. If you want to retain the base 5, that also can be done. So x would be log of base 5 of 5 over 12. Either way, you're getting the same answer. So ln 5 divided by 12 divided by ln 5 1. So we need the answer in 3 decimal places, so 5 4 4. So therefore x is equal to minus 0.544. All right, moving on to the next question. The complex number u is given by cos pi by 7 plus iota sine pi by 7 raised to power 4 and minus 7. So if z is equal to cos 1 over 7 pi plus iota sine pi 1 over 7 pi, so that would mean its own conjugate will be cos pi by 7 minus iota sine pi by 7 pi. So that means we can find out the magnitude and the argument right away so that we can help it. So mod of z is 1. However, the argument of z is just simply pi by 7. We don't even need to do that. So pi by 7. This one, on the other hand, is also 1. And the argument of z conjugate is minus pi by 7. Why? Because cos of minus negative number or negative angle is basically the same thing. So if it's minus 1 over 7 pi, it would be the same as 1 over 7 pi because it's an even function. However, the sine minus 1 over 7 pi would be minus sine positive 1 over 7 pi. So sorry, my bad. Let's rewrite it. So 1 over 7 pi. So argument of complement, this is minus pi by 7. Now, z raised to power 4, we know that the magnitude of z raised to power 4, because this is z raised to power 4, is z raised to power 4, which is 1. And the argument of z raised to power 4 is going to be 4 times by argument of z, which is 4 pi by 7, which, if you notice, is still between 0 to, sorry, no, minus pi to pi. Argument of any complex number should be between minus pi to pi. So it is in between that range. So what we have over here now, that u is z raised to power 4 over z conjugate. So that means the magnitude of u is the magnitude of z raised to power 4 divided by magnitude of z complement. So 1 over 1, basically 1. However, the argument of z raised to power 4 over z complement is the argument of z raised to power 4 minus argument of conjugate z. So that is 4 pi by 7 minus, this is already negative, so minus pi by 7, that becomes 5 pi by 7. So therefore, u can be written as, argument u, So argument u can be written as 5 pi over 7. So this is our final answer. All right. The complex number u and u conjugate are plotted on the Argand diagram. Describe the single geometrical transformation that maps u onto u conjugate and state the value of argument u. So to do that, we need to see where they are. Okay, so for the argument u, it's 5 pi by 7. So to see where it actually is, so 5 divided by 7 times by 180, 128. So u is somewhere over here with the angle, whatever this is, 5 pi over 7. This is our u. For u conjugate, we will have minus 5 pi by 7. So that will be the opposite in the third quadrant over here. So this would be the minus 5 pi by 7. And this would be the u conjugate. So we can see this over here, that this is plainly a reflection in the real axis. So this is real, this is the imaginary axis. So u can be mapped onto u conjugate by reflection in real axis, real RE axis. All right, straightforward. Let's move on to the next question. The variables x and y satisfy the equation ay equals to b raised to power x, where a and b are constants. The graph of L and y against x is a straight line passing through the points as shown in the diagram. Find the values of a and b. All right. So first off, we have ay equals to bx, which can be converted into the ln form, ln a plus ln y equals to x ln b. Oh, sorry, no, ln y. So ln y would therefore be x ln B minus ln A. So let's do this. There are two ways to solve this problem. Since we have two unknowns, B and A, we can plug in these 2 points as two different equations and we will get B and A. Or we can do this by the gradient and then the ln. So this the rate of change over here will get us the gradient, which would be ln B. So let's try both methods and see which one do you like better. So okay, so let's see first the point method by first making two simultaneous equations. So we have ln y value is, sorry, no, we already have that, sorry. Ln y value is 8.27 equals to x 3.4 ln b minus ln a. This is your first equation. Second equation is going to be 2.24 equals to 0.5 ln b minus ln a. This is your second equation. So how we can solve this is by subtracting these equations together. So minus minus plus, this cancels out, leaving us with 8.27 minus 2.24. We get 6.03 equals to 3.4 minus 0.5, that is 2.9 ln b. So ln b is 6.03 divided by 2.9. So b would be exp 6.03 2.9. So, oh, sorry, 6.03 divided by 2.9. We will keep it as it is for now. This actually becomes one significant figure, so this would approximately become 8. For a, we can use either one of these equations. So ln of a would be 3.4 ln b minus 8.27. So ln b is basically this value, so 3.4, 6.03, 2.9 minus 8.27. So we get 3.4 times by 6.03 divided by 2.9 minus 8.27. So with the bid mass, we are getting this value minus 1.2. So this value, so a would be exponent of minus 1.2. So e raised to power answer, we get 0.3. So these are the two values, oh sorry, these are the two values that we are getting. So, sorry. Right. Now let's try another method by taking the gradient and equating with ln b. So ln b would be equal to gradient. So that would be 8.27 minus 2.24 divided by 3.40 minus 0.5. So 8.27 minus 2.24 divided by 3.4 minus 0.5, we get this value, fraction is 603 and 290. And as you can see, this is basically this equation over here. So that means the B would be the e raised to power 603 to 90. This is exactly what this is. Now, to find out A, we need to plug in anything over here. So for ln A, we plug in either one of these 2 points. So let's plug in the first one this time. So you have x. ln B is basically 603 to 90 minus ln y. So ln y is 2.24. So 2.24. Right, okay. So 0.5 times by 603 divided by 290 minus 2.24. We get the same thing, minus 1.2, exactly what we had over here. So A you will get as exponent of minus 1.2, exactly same as 0.3, and this would yield us approximately 8. So we needed to one significant figure each. So therefore, A is 0.3, B is 8. All right, so let's move on to the next question. Show that the equation tan cubed x plus 2 tan 2x minus tan x may be expressed as this. Okay, so that means in tan x. So first off, we need to deal with the tan 2x. So tan 2x can be written as 2 tan x 1 minus tan squared x. That means when we plug this over here, we get tan cubed x plus 2 times by 2 tan x 1 minus tan squared x minus tan x equal to 0. Now what we can do over here, we can multiply both sides by 1 minus tan squared x because we don't want any fractions. So this becomes tan cubed x 1 minus tan squared x plus 4 tan x minus tan x 1 minus tan squared x equal to 0. So what we have over here, tan cubed x minus tan raised to power 5x plus 4 tan x minus tan x plus tan cubed x equal to 0. Now simplifying this further, you have minus tan raised to power 5x, tan cubed is 2x, 4 minus tan, so 4 tan x minus tan x is plus 3 tan x equal to 0. If we take out, we can reverse the signs over here. So this becomes tan x, tan raised to power 4x minus 2 tan squared x minus 3 equal to 0. Since tan x is not equal to 0, that means tan raised to power 4x minus 2 tan squared x minus 3 equal to 0. So that's the first part. Hence solve the equation tan cube 2 theta plus 2 tan 4 theta, 4 theta 0 to pi. Alright, so if theta is between 0 to pi, then 2 theta will be from 0 to 2 pi. Alright, so we will solve this like a quadratic equation. So we have tan raised to power 4 2 theta minus 2 tan squared 2 theta minus 3 equal to 0. Right, so solving for tan squared 2 theta, we can do this with a quadratic form over here. So we take u as tan squared 2 theta. This would transform it into u squared minus 2u minus 3 equal to 0. So let's see if we get any factors. So u squared minus 3 minus 2u. So u, 3, and 1. Yes, so 3u, u, minus 3, minus 3. All right. So we get u minus 3, u plus 1 equal to 0. U is either 3 or u is minus 1, which results in tan squared 2 theta, either it is equal to 3 or tan squared 2 theta minus 1. The second one obviously will be discarded because no solutions can come from square root of minus 1. No real solutions can come from that. However, this one, when you do the square root, you will get plus and minus square root 3. So that means we need to know from 0 to 2 pi first. So tan is positive in the first and the third quadrant. Positive, positive. So 2 theta would be tan inverse of root 3, or 2 theta would be equal to tan inverse of negative root 3. So this would result in a positive answer. So radians tan inverse of square root 3, that would be pi by 3 basically. So pi by 3, and the other one would be pi plus pi by 3, so 4 pi by 3. Second one leads us to minus, so this would be either this pi by 3 or this pi by 3. So for the other side, we have pi minus pi by 3. So that would be just 2 pi by 3. And 2 pi minus pi by 3 is 2 minus 1 divided by 3 is 5 over 3 pi. Okay, now the thetas would be pi over 6, 4 divided by 6 pi, so that would be 2 over 3 pi. And from this, we will get pi by 3 and 5 over 6 pi. All right, so now arrange in total. Therefore, theta is 1 over 6 pi, 1 over 3 pi, 2/3 of pi, and 5/6 of pi. All right, so that's the answer. All right, moving on to next question. Parametric equations of a curve are x is equal to tan squared 2t, y is equal to cos 2t for 0 to t to 1 over 4 pi. Show that dy by dx is this. Okay. So x is equal to tan squared 2t and y equals to cos of 2t. So dx over dt, first off we will have 2 tan 2t times by the derivative of tan, which is going to be secant squared, same angle 2t, and then the derivative of 2t, which is 2. So you have 4 tan 2t secant squared 2t. Now the y dy by dt is going to be simply derivative of cosine is minus sine, so minus 2 sine 2t. So this can be further written as 4 sine 2t over cos 2t times by also cos square 2t. So cos cubed basically. So dy by dt is this. So dy by dx is dy by dt divided by dx over dt. So dy by dt is this minus 2 sine 2t divided by this thing 4 sine 2t divided by cos cubed 2t, which leads us to minus 2 sine 2t times by cosine cubed 2t divided by 4 sine 2t. So sine 2t get cancelled, and 2 times by 2 is 4. So minus 1 over 2 cosine cubed 2t. That is your dy by dx. All right, let's see forward. Hence, find the equation of the normal to the curve where t is equal to pi by 8. So first off, we need to find the dy by dx at at t is equal to pi by 8. So minus 1 over 2 cos cubed of pi by 8. Sorry, 2t. So times by 2. So you have minus 0.5 times by cosine of pi by 4 cubed. So let's see if there's, oh yes, there's an exact answer, minus square root 2 over 8. So this means that the gradient of normal is going to be minus 1 over square root 2 divided by 8, which is, sorry, minus that, so plus, basically. So plus 8 over square root 2, that is 8 divided by square root 2 is 4 square root 2. Right, okay. Now we need the equation of the line. So we will go y minus y1, mx minus x1. So y function was cos 2t, and that was tan squared 2t. Okay. So y minus tan squared. Now the value of t was pi by 8, so times by 2, pi by 4. Gradient is 4 root 2 x minus, sorry, this is supposed to be cos 2. Cos pi by 4 and x minus tan squared pi by 4. Okay, so we know the common functions that cos pi by 4 is root 2 over 2 and tan pi by 4 is 1. So this becomes y minus root 2 over 2 4 root 2 x minus 1 because squared value. So multiplying both sides by 2 gets us 2y minus square root 2 equals to 8 square root 2 x minus 1, which is 8 square root 2 x minus 8 square root 2 plus root 2 equals to 2y. So therefore y would be, these two will add up to minus 7 root 2. So 4 root 2 x minus 7 root 2 over 2. So that is your answer. That's it. All right. Moving on to ninth question. With respect to the origin, the points A, B, and C have position vectors this. The point D is such that A, B, C, D is a trapezium with DC is equal to 3AB. So trapezium, so A, B, C, D. So this is 3 times that. All right. Find the position vector of D. Okay, so we have A and B. Okay, so this part is easy. So now this is the vector scalar multiplication with the vectors. So ODC can be written as OC minus OD, and AB can be written as OB minus OA. So OB minus OA would be 0 minus 2 minus 2, 4 minus 1, 3, and 1 minus minus 3, 4. Right. So since we have DC is equal to 3, and this is the unknown over here, what if we take what if we reverse the sign on both sides? So that would be the same then. So we would have OD minus OC is equal to minus 3 times by AB. So OD would be minus 3 times by minus 2, 3, 4 plus OC, which is minus 3, minus 2, 2. This would become 6 minus 3, 3, minus 9 minus 2, minus 11, and minus 12 plus 2, minus 10. So that is your position vector. The diagonals of the trapezium intersect at point P. Find the position vector of P. Okay, so we have to find the line equations first. So dB and DC. So first what we do is we place this over here. So we don't forget this. D we have over this. So we have two lines over here, DB and AC. So line through DB would go OD plus lambda DB. So OD is 3 minus 11 minus 10 plus lambda. DB is going to be B minus D. So 0 minus 3 minus 3. 4 minus 11, so 15. And 1 minus 10, that is minus 11. But plus 11. So we get 3 minus 3 lambda minus 11 plus 15 lambda and minus 10 plus 11 lambda. Now the line through the AC, so that would go OA plus mu AC. So OA is 2, 1 and minus 3. Mu AC is now C minus A, so minus 3 minus 2 minus 5. Minus 2 minus 1 minus 3. And 2 minus 3, 5. So 2 minus 5 mu, 1 minus 3 mu, and minus 3 plus 5 mu. Alright, so now we equate these one by one. So 3 minus 3 lambda is equal to 2 minus 5 mu. Minus 11 plus 15 lambda is equal to 1 minus 3. So these, when we bring unknowns on one side, you will have 5 mu minus 3 lambda. 2 minus 3 is minus 1. Then we have 3 mu plus 15 lambda equals to 1 plus 11, that is 12. So to solve this, we would need to multiply the first equation by 5. So we would have 25 mu, minus 15 lambda minus 5, 3 mu plus 15 lambda is equal to 12. So we don't even need to change the sign. This would cancel. 25 plus 3 is 28. Mu, 12 minus 5 is 7. So mu would be 1 over 4. Now we need to figure out the other one. So for the other one, we can use this one. So 3 minus 2, 1 plus 5 mu is divided by 3 would be lambda. So lambda would be 1 divided by 4. So 1 plus 5, answer divided by 3 is 3 by 4. Right, okay. So we just need to use one of these basically. So point P would be OP. We just need to plug in into this, let's say the second equation, 2 minus 5 mu, 2 minus 5, 1 over 4. 1 minus 3, 1 over 4, and minus 3 plus 5, 1 over 4. All right, so let's go with finding this out. So 2 minus 5 divided by 4 is 3 by 4. 1 minus 3 by 4, 1 over 4. And minus 3 plus 5 divided by 4 is minus 7 over 4. So that is your position vector of P. All right. Using a scalar product, calculate the angle ABC. All right. So over here, we have to take the scalar product. So the diagram that we made over here, so we need this angle over here, right? So either both of these going into or both of these going out. So BA, BC, BA and BC. All right. So BA dot BC equals to BA BC cosine of theta. So BA is 0 minus 2, 4 minus 1. Sorry, no. It's the other way around. So A minus B, sorry. So 2, 1 minus 4 minus 3, and minus 3 minus 1 is minus 4. Dot BC, that means C minus B. So minus 3 minus 0, minus 2 minus 4. So 2 minus 1 is just 1. Just to check, BA is A minus B. 2 minus 3 minus 4, minus 3 minus 2 minus 4, and 2 minus 1. All right. Now the length BA would be 2 squared plus 3 squared plus 4 squared times by square root of 3 squared plus 6 squared plus 1 times by cos of theta. So 4 plus 9 plus 16 times by square root of 9 plus 36 plus 1, that is 1334 cos theta, and the left side dot product minus 6, 18 minus 4. So 18 minus 10 is 8 basically. So cos theta is 8 over 1334 root. So cos inverse of 8 divided by square root of 1334. So theta is 77.3 degrees. All right. A balloon in the shape of a sphere has a volume V and a radius R. Air is pumped into the balloon. That means volume is increasing at a constant rate of 40 pi. Starting at time t is equal to 0 and r is equal to 0. At the same time, air begins to flow out of the balloon at the rate of 0.8 pi r. The balloon remains a sphere at all times. Show that r and t satisfy the differential equations. Okay, so first off, we know dv over dt. First, it is increasing at the rate of 40 pi per second or per unit time, and then at the same time minus 0.8 r also. Right. Now, since this is a sphere, this is 4 over 3 pi r cubed. So dv over dr is 3 comes down, so that would be just 4 pi r squared. So this means, right, so dr over dt would be dr over dv times by dv over dt. Right, so dr over dv is the reciprocal of this. So 1 over 4 pi r squared times by 40 pi minus 0.8 pi r. So pi cancels, and 40 divided by 4 is 10 over r squared minus 0.8 divided by 4, oh sorry, 1 over 5, r over r squared is just r. So when we make the denominators constant, so 5r squared, so 50 and then minus r. So that's it. That's your dr over dt. Simple chain rule. Find the quotient and the remainder when 50r squared is divided by 50 minus r. So we can use the long division over here. So 5r squared, 50 minus r. So if we look at this, we need to multiply with this minus 5r. So we get 5r squared, and then 50 minus 5r, that would be 250r. So minus plus, that would be 250r. So a common mistake is to start over here. How do we know? You have a 250r and a 50 minus r. So basically r and r terms. So single r, basically, single power. So that means we can go further over here. So what we do is we just need to multiply our divisor with minus 250 further to get the required term. So this would be minus r minus 250. That is just positive 250r, and minus 250 times by 50 is minus 12500. When we subtract, we change the signs. We get 12500. This is the remainder. So how do we express this all as a mixed fraction or mixed expression? 50 minus r is identical to minus 5r minus 250 plus 12500 divided by 50 minus r. So that's it, basically. All right. Solve the differential equation in part A, obtaining an expression for t in terms of r. So what we can do over here, we know that dr over dt, we wrote it as 50 minus r, 5r squared. Now when we have to separate the variables, we get 5r squared over 50 minus r dr equals to dt. So we have to integrate those. The expression on the left side over here, we have already expanded it. Minus 5r minus 250 plus 12500 divided by 50 minus r dr equals to t plus c. So integration of the left hand side is easy. This will become 5r squared over 2 minus 250r. Now, this will be handled by ln. How? Because you have 50 minus r in the denominator, we need minus 1. We already have 12500 over here, so we multiply this by another 1. So we make it into 12500 ln 50 minus r and equals to t plus c. Now they gave us a condition in the start that at t is equal to 0, r is equal to 0. So when we plug this in, we have 0 minus 0 minus 12500 ln 50 equals to 0 plus c. So that means 0 is minus 12500 ln of 50. We need the expression for t in terms of r, so we just need to take c on the other side. So t will be minus 5 over 2 r squared minus 250 r minus 12500 ln 50 minus r minus 12500 ln of 50. That's it. That's an expression that we want. All right, so moving forward. Find the value of t when radius of the balloon is 12. Okay, so we just have to plug it over here. So when r is 12, t will be 5 over 2, 12 squared, minus 5 over 2, minus 250, 12, minus 12, 500, ln, this was supposed to be ln 50 minus 12 minus 12500 ln of 50. So now we just have to plug in the values. So minus 5 divided by 2 times by 144 minus 250 times by 12 minus 12500 ln 50 minus 12 minus 12500 ln 50. So we get this value. Wait, did I make a mistake over here? Oh, c was already negative, so over here it becomes positive. So this becomes positive over here. So the last term is positive. So t is going to be 70.5. That's it. All right, moving on. Let f of x be 2e raised to the power 2x divided by e raised to the power 2x minus 3e raised to the power x plus 2. Find f prime of x and find the exact coordinates of the stationary point of the curve with equation y is equal to f of x. All right, so this is easy. We have to use the quotient rule over here. So u is equal to 2e raised to the power 2x. U prime would be 4e raised to the power 2x. V is e raised to the power 2x minus 3e raised to the power x plus 2. V prime would become 2e raised to the power 2x minus 3e raised to the power x, and that's it. So d f prime of x would be v u prime minus uv prime over v squared. So vu prime is 4e raised to power 2x times by e raised to power 2x minus 3e raised to power x plus 2 minus uv prime 2e raised to power 2x 2e raised to power 2x minus 3e raised to power x divided by v squared, which is the square of e raised to power 2x minus 3e raised to power x plus 2 whole square. So we expand the brackets. We get e raised to power 2x times by e raised to power 2x becomes 4x. So 4x minus 12 e raised to power 3x plus 8 e raised to power 2x minus 4 e raised to power 4x plus 6 e raised to power 3x divided by e raised to power 2x minus 3 e raised to power x plus 2 whole square. So some terms you see that they can be cancelled. So 4 e raised to power 4x, this cancels. And all right, so this term and e raised to power 3x term will be simplified a little bit further. So you have 8 e raised to power 2x minus 6 e raised to power 3x divided by e raised to power 2x minus 3 e raised to power x plus 2 whole squared. That is your f prime of x. Now, for stationary point, f prime of x is equal to 0. Therefore, 8 e raised to power 2x minus 6 e raised to power 3x equal to 0. We take them on the each opposite sides. 6 e raised to power 3x, we divide, cross multiply. So e raised to power 3x divided by e raised to power 2x, 8 divided by 6. This becomes 3x minus 2x is x, 4 over 3. Therefore, x would be ln of 4 over 3. So that would be the final answer. This would be the x coordinate. We need to find the y part also. So that was, all right, y e raised to 2e raised to power 2x. So 2 ln 4 over 3 divided by, we have e raised to power 2x. So 2 ln 4 over 3 minus 3 e 4 ln 4 over 3 plus 2. Right, okay. So first things first, this is easy to handle over here. It's not that big of a deal. So when you have e raised to power ln function, let's say if this is 4 over 3, the answer would be 4 over 3. But when you have e raised to power 2 ln 4 over 3, the answer would be the 4 over 3 whole squared, so 16 over 9. So that's all we have to do over here. So 2 times by 16 over 9 divided by, again, 16 over 9 minus 3 times by 4 over 3, that's just 4 plus 2. So 2 times by 16 divided by 9. 16 divided by 9 minus 4 plus 2, you get minus 16. So coordinate is x is equal to ln 4 over 3, y equals to minus 16. All right. Use the substitution u is equal to e raised to power x in partial fractions to find the value of this ln 3 to ln 5 f of x. Give your answer in the form of ln a. Okay, so f of x was 2e raised to power 2x divided by e raised to power 2x, a minus 3e raised to power x plus 2. Yeah, right. Okay. So this we already, over here, if u is equal to e raised to power x, then u squared would be the e raised to power 2x. And when x is equal to ln 3, u would be just 3. And for 5, u is equal to e ln 5 would be just 5. So we have decoded everything we need to do for the substitution. So when we want to put it this way, this will become a integral of 2u squared divided by u squared minus 3u plus 2. Now, sorry, I forgot one thing. We have dx also. So if du over dx is also e raised to power x, which is u, so du, or sorry, dx would be du over u. So remember, this is u, by the way, right? So du over u. So this would become 1 over u du. So this will essentially cancel out with this over here. Now notice, yeah, so sorry, notice that we can't actually solve it like this form over here. So we will have to do the partial fractions over here. So 2u, u squared minus 3u plus 2. So we first, oh sorry, we need to factorize this first. So we factorize this over here. So u squared 2, 3u. So this is minus 2 and minus 1. And un. So minus 2u minus u. So this becomes u minus 2, u minus 1. Right. So this would be turning into a over u minus 2 plus b over u minus 1. Right. So this is easy. So 2u identical to a u minus 1 plus b u minus 2. Furthermore, when we plug in u is equal to 1, we get 2 minus b. So b is minus 2. When we plug in u is 2, we get 4 a. So a is 4. So therefore, we have integral of 2u, the a is 4 over u minus 2 plus u minus 1 this minus should come over here. So du from 3 to 5. Right, okay. Now this is easy because this is just all just ln. So 4 ln u minus 2 minus 2 ln u minus 1 from 3 to 5. This becomes 4 ln 5 minus 2 is 3 minus 2 ln 5 minus 1 4 minus 4 ln 3 minus 2 is 1 minus 2 ln 3 minus 1 is 2. So ln 1 is 0. So this term will go out 0. So you have 4 ln 3 minus 2 ln 4 plus 2 ln 2. ln 4 can be represented as 2 ln 2 also. So this can be written as 4 ln 3 minus 4 ln 2 plus 2 ln 2, 4 ln 3 minus 2 ln 2. All right, so let's see in what form did they want. Give your answer in the form of ln a. So we need to further simplify this. So ln 3 raised to power 4, which is 81, and ln 4. So ln 81 minus ln 4. So that would be ln 81 over 4. So that's the simplest form of the answer. And finally, that was the last question. All right, so if you feel I was unable to explain some question properly, please reach out in the comments. If you like this video, please appreciate that if you would leave a kind comment. Don't forget to like and subscribe to our channel. It means a lot to see the engagement from our students. So see you in the next video. Bye bye.